Okay. So we're pretty stoked to have this workshop this evening with Shannon Pileggi on debugging. I know this is a topic that's been requested by Our Lady's user or participants in the past. And so, we're all really excited about it. Before we get started, we just wanted to remind you all that Our Lady's has a code of conduct that everyone participating must agree to. And there's a link on the screen here where you can read the full version. But just a short excerpt is Our Lady's is dedicated to providing a harassment-free experience for everyone. We do not tolerate harassment of participants in any form. We want these meetups to be safe and friendly for everybody. And we'd also like to plug our new YouTube channel where we're putting all of the recordings of our meetups. So this will be where all of the recordings live after the meetups if you want to watch them, or if you've missed a meetup and want to see it, those will be on there. So we're pretty excited about that. And so just to quickly introduce Shannon, she is a lead data scientist at the Prostate Cancer Clinical Trials Consortium. She's also a frequent blogger, and she's also a member of the global team at Our Lady's, which is super cool. She enjoys automating data wrangling and data outputs and making both data insights and learning new material digestible. And with that, I'll stop sharing on my end and pass it over to Shannon.
All right, thank you all so much for having me. I'm excited to be here. This is one of my favorite workshops to teach because I think it's really meaningful content that really helps you be better at programming in an incredible way. I am just going to get everything situated where I need it. So what we're going to be talking about today is debugging. And this content I've covered in a 3-hour workshop before, so we're not going to have sufficient time to do all of the content, but the last hour is kind of like the icing on the cake anyway, and stuff that I don't really use on a day-to-day basis. So we're going to get to the things that you might want to use on a day-to-day basis for sure. This work is actually part of what they forgot to teach you about our workshop that's been held at our studio conference and now Posit conference for several years now. So it's been part of other workshops as well. If at any point during the discussion you have questions, feel free to drop them in the chat. I'll do my best to keep an eye on that. And also the co-hosts are welcome to interrupt me and say, hey, can we pause and address this question as well? And of course, if I say anything too fast or do anything you didn't quite see, I'm happy to repeat anything. So if you're doing this on your own, this is kind of what you might need to do it on your own. You might need our studio, and you might need to be ready to build packages for one of the exercises that we do. But if you don't want to do that, that's fine, because we've got the Posit Cloud instance, or I can demo for you. There are a lot of resources out there about debugging if you want to go for more information after this talk. And I should probably go full screen. And here's just a cute little artwork. Oh, do you know this person? Is this, Allison Horst? From Allison Horst about debugging. I don't know if you've seen this. There's a lot of emotional stages that you go through when you do debugging, including the zombie meltdown, which happens to me quite a bit. But when you get to the end of it, it does feel triumphant. And you also learn a lot from the debugging process as well. Before you get to these formal debugging tools, though, you have to do your due diligence and troubleshooting. So there are like really simple steps you can take before you dive into these tools. So I think I don't want to spend too much time on it, but like you should do this. So one, you should search the error message that you're getting, right? You can search on our RStudio community, and you can search on Stack Overflow. And of course, Sam gave a great talk for Our Lady St. Louis and probably other organizations about Teach Me How to Google. So definitely check that out. A really important concept in debugging is turning your R off and on again. So, and the reason why this gets really important is you want to restart R, like definitely when things get weird, but this is really works best when you have these specific settings on your R installation. So in RStudio, you would go to Tools, Global Options, and Workspace. And the ideal settings are to never restore our data into Workspace at the startup and never save our data on exit. So this is going to make sure that any code you write, any artifacts you produce can be reproduced and you're not reliant upon what's in your workspace. So turn it off and on again. You can restart R. And the way you would do that is going up to your menu and you would do Session, Restart R. You can do Control-Shift F10 on Windows, Command-Shift-0. But again, this works best when you have these settings on your RStudio instance. So if I'm talking about, you might not have the same settings as me. If you're working independently, this is one of the settings I have. Any questions about that setting? Okay.
I actually did, Shannon.
Yeah.
Our data, is that like everything that you run in RStudio that gets saved as our data? And if this is turned on, then all of those objects and everything will be reloaded each time. I don't think I've ever had this turned on, but I never actually really totally knew what it meant to turn it on.
So when you don't want it turned on, you want it turned off.
Or sorry, off. Yeah.
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 And so if you don't have it turned off, when you open your R session, even if you just reboot your laptop and open your R session is probably going to populate with lots of different objects, right? If you have these options turned off, then your R session will not populate with anything. And you're going to start with a blank slate every time you open R. And starting with that blank slate forces you to write code that is reproducible. And it also allows you to more quickly iterate and troubleshoot. So it is a lifestyle change. It's something you can't have these like projects. You're like, I don't know how to get that data set back, and like hanging on to it. But it's a worthwhile change that I recommend, and I can drop some more links in later about that if you want. Are there any other questions? All right. So I'll just show you real quick on the RStudio Cloud instance. I need to move this banner. Okay. How you're going to do that. So here I am in my RStudio Cloud instance. And again, I'm going to go to Tools, Global Options, and I'm going to go down to my workspace. And I guess maybe these options are already set in mine. I can't remember if you're opening the RSposit Cloud, sorry, it's the Posit Cloud instance. So the default probably looks like something like this, where this is checked, restore, and it says always. So you just want this to be unchecked and you want it to say never. And that's how you would do that. And then you would scroll down and say, okay. So that means if you go and create the object X with a value of 2, and then you go to restart R, 2 is no longer there. Any questions? All right. Oh, I clicked on the link. Okay. Another tool you can use for troubleshooting is to create a reprex. Like if you have an error and you're not quite sure how that error arose, it could be from some sort of like really complicated code. And the simplest way to get to the essence of it is to create this minimum reproducible example, otherwise known as reprex. And my favorite reprex talk is from Charlotte Gelfand in 2021, Make a Reprex, Please. I highly recommend it. So here's her slides and her recording. So we're not going to get into the art of making a reprex, but it is the best way to like really fine tune what your error actually is. And the reason why you would make that reprex is because of like, if you have this really long, like huge complicated code, like you've got a needle and a haystack to find. So try finding that needle in a smaller stack. And another reason is because like you might think that you're saying or doing something, but then there's also like what you're actually doing on the other end, and those don't always line up. So reprex makes it explicitly clear. And it's going to help you solve your own problems. So every time I go to make a reflex, I generally, and I'm like, okay, I got to get this on Stack Overflow, or I got to get this to some Our Lady's help. And then I'm like, oh, I figured out the problem. All right, so for our troubleshooting strategies, you can Google search, you're going to reset restart your session and make a reflex. But if that fails you, you might actually need to use some formal debugging strategies. And this is particularly helpful in the context of maybe when you're writing your own functions. I use them a lot to kind of figure out what's going on and how to improve them. But you can also use them on other people's functions as well. So we're going to talk about formal debugging techniques. So some of the key concepts of these debugging techniques are the traceback, which is the location of where the error occurred in your function. You can also trigger an interactive debugger, which is my favorite tool to use, and it provides context on why did the error occur. And then another feature of these debugging tools that we're going to be looking at are debugging tools that you can use for your own code, like if it lives locally on your machine, and that's going to be indicated by this magnifying glass. But there's also debugging tools that apply to someone else's code. So maybe a package that you installed from Crayon. You don't have the source code for it. It's not on your local machine, but you can still break into it using debugging tools. And so that's indicated by the wizard tab. These are all of the debugging tools that are covered in this deck. And so I've separated them out into functions, options, and things you can do in the RStudio IDE. And so you can see some of them might supply a traceback, some of them might open the interactive debugger, some of them work on your code, and some of them work on their code, and some of them work on both. So there's a lot to choose from here. There's a lot of ways you can go about debugging. It's a lot, it's overwhelming. They really achieve similar objectives, just a little bit differently. And people do not use all of these tools. Like they pick one that they like and they use it a lot. So don't feel like you need to use it. I'm just going to try to expose you to all the tools that are out there. All right. So one more concept with debugging, especially if you are working locally and maybe you're not even working in a package, but you just got some functions that you're using on the side, playing around with, iterating on. What you want to do if you want to employ debugging tools on those functions. You want to have a separate script with those functions saved in that script. And then you want to source your script with those functions for the best debugging experience. So I'm not going to go into Posit Cloud here. This is going to just be my regular R instance. And so what I say by sourcing my script is over here. Oh, I meant to change one setting real quick. Let me do that on the side. Type any questions in the I just wanted my environment to look clean for you all. All right. Perfect. Okay. So what I mean by sourcing the script. So if I am over here, I've got my environment, it's empty. This is just a random project for development. This is not what's in Posit Cloud. And let's see here, I highlight and I run these functions and then I hit enter. That is not sourcing. So that is just like loading these objects into my workspace. So you can see I have like functions in my environment over here. So what I mean, and I'm going to go ahead and restart R. So this is really important to debugging. So now I have nothing in my environment. So what I mean by sourcing is literally clicking on this source button. It doesn't look any different than when I just highlighted and ran the functions in my environment, but it does give you actually some additional abilities that you're going to see quickly when we start debugging. Are there any questions? Okay. So we have sourced in these functions. I'm going to switch back over to my R over here. And so we have this function f. I was playing around earlier. Let me delete this. Let me restart R. This is very iterative. All right, and now we're going to source these functions again. All right, so now we have a function f that just adds 1 to x. So if I do f, and then g is just the same as f of x. So if I do g of 1, we don't get an error, right? 1 plus 1 is 2. But what if I do g of a? So now I'm going to get an error because we can't add 1 to a character value. So we have this error that's hard to digest, non-numeric argument to binary operator. All right. So now we've created an error, and what are things we can do about that? So this is our code, right? Like this is a script I have with my own functions, and I sourced it in. So this is my code that I want to debug. There are some methods I'm not going to demo that are kind of like historically been used for ages. So there's print methods where you can print values, like create lines in your functions that print certain values so that when you get to errors, it kind of helps you troubleshoot like, well, what was the value that was in there? So you can use print statements. You can also use cat statements to give you a little bit more context or a description about things, but I don't want to focus too much on that because I want to get to the really good stuff. These are just historical methods that have been used. So let's get to the real debugging tools here. The first one that we're going to talk about is a traceback. So this is going to show you the sequence of calls that led to that error. So again, if we're thinking about this kind of roadmap here, so traceback is where did the error occur? All right. And this is a base R function. So we have this error here, and now I type traceback, and it only works when you have like the last thing that happened is an error. So now you can see a sequence of steps. That first you called the function g of a, and then that function g of a at row number 5, it actually tells you the location of that error called f of x. And then that's when that error occurred. So this is why the sourcing is really important because it really gives you those line numbers. If you don't source, you're not going to be getting those line numbers of where the error actually occurred. The traceback works when you have triggered an error last. So G of 1, I guess it's just telling you the traceback for the last error triggered anytime you call traceback. And again, that's a base R function. There's a slightly different version of traceback that you can use. And I know it's like a little hard to digest because it's like there's like one step. You're like, what exactly am I looking at? So the exercises are going to show you a slightly more complex step. There is a different version of the traceback you can use. So if you want to use an option from the rlang package, so option error equals rlang : in trace, it gives you a different picture. So I'm going to copy this real quick. I'm going to go over here and I'm going to restart R. I am going to source in, I'll clean this. Well, no, I'll leave that there so we can scroll up. I'm going to source in my demo functions. I'm going to set that option. And now this option is set for my entire R session until I restart R again, or I can turn it off as well. Now I'm going to trigger an error with G of A. Again, you see that same error message, but it says, maybe you want to run rlang last trace to see where that error occurred. So I'm going to pop in rlang last trace there. And you can see that it gives you a slightly different view. So it's kind of like a more nested view of like what function might call what. And it tells you also where the functions live in terms of what environment. So G of A lives in your global environment. It'll tell you if it lives in a package or somewhere else. And it tells you like even the row, and I think this is the column of like where that happened. So row 5, column 5 is where that got triggered. I know I also had last error in my notes, and I think these used to give like different outputs, but now They are not giving different outputs. So for me, they're interchangeable at this point. But maybe when I think it's when the error you're tracing back is more complex, you'll probably see different outputs. So we have talked about two ways to look at where your error occurred. We've talked about the base R traceback function and setting your options via rlang, so you can call it rlang last trace. If you really like the way this looks, you could put something like this option in your R profile as well. And if you want to know more about how to do that, I can certainly tell you. Are there any questions? All right. The traceback and the rlang functions, they do differ in like the order of the presentation. So I know I went over it super quickly, but when we did like the traceback, it said like 1, then 2, right? And it kind of worked its way back up. And the rlang functions, just so you know, like do work their way down. So the ordering is reversed between the traceback and the rlang functions. And this is an image from advanced R debugging section, if you want to just see more detail about that. All right, so now we are going to use the browser function. And the browser is what allows you to open something called the interactive debugger. And it's pretty cool if you've never been in it before, because you've probably all done debugging where you're like trying to assign values to arguments like one at a time and then like run them through your function and then see what happens. The interactive debugger allows you to do this so much more quickly and efficiently. So the first way we're going to talk about how to launch the interactive debugger is by inserting the browser statement into the body of your function. And then we're going to source the function and execute the function as usual. Now the browser statement can go anywhere into the body of your function. So I'm going to restart R to start with a clean slate. So it can go at the top line of your function. It can go after 10 lines of your function, wherever you want. And wherever you put the browser statement, all of the code that is above it will automatically be executed. So you can kind of determine where you want to open your interactive debugger by the placement of your browser statement. So now I've got my browser statement into my function. Now I'm going to source it. And nothing looks different on the outset. But what happens now, I'm not even going to trigger an error. I'm just going to do what we know works. I'm going to try to add 1 + 1 with G of 1. And what browser does is it automatically opens your interactive debugger. So we are in interactive debugger land. You can see a few different clues that tell you that. So one, we have this browse statement with a prompt. That means we're in the debugger. You can see kind of there's this new menu here that wasn't there before. That's from the interactive debugger. You can also see that we're looking at a traceback screen over here. It kind of shows you where you are. And really cool over here, you're in your environment for your function. So this is a clean, pristine environment, not populated at all by what's in your global environment. It is only what is going into your function call. So the only value that is going into my function call right there is X. Now, the way this works is it works just like any R code. This is a prompt, and you can put any R code that you want into this prompt. So I can say, what is the value of X? And the value of X is 1. I can say, what is the structure of X? And it's going to tell me the structure of X. I can say, is it this one? ls.stir. Like list all objects and their structures. That didn't quite do, oh, not of X, ls.stir blank. It's going to give me all objects and their structures as well. And I can create a new object if I wanted to, right? Like Y is a value of 3. If I can do an assignment operator. All right, and so now I'm in my function environment. I've created this new object that's a value of 3. So like it is just your usual command prompt. You can do anything you want here, any R code. But where the power comes in is to be able to navigate through the steps of your function and see what you have in this function environment. So you can use key words, key letters here. So I'm going to type in the key letter in, and it's going to go next. So it went from my browser statement, and then my highlighting is now on my x+1 statement. So x+1 has not yet been executed. It is ready to be executed. And then if I hit next again, it's going to execute that statement. Now that statement worked successfully, so it just printed the results and closed the interactive debugger. So I'm going to open up that interactive debugger again on G of A. Again, I'm back into my interactive debugger. I can look at the value of A, or I can say ls.stir, open close prints, say, oh, X is a character value of A. I can go to next, and I can see, all right, so now let's execute this statement. And that's when I actually yield the error, and it's going to close out the interactive debugger. And I think once you see the exercise examples that are a little bit more rich and complex, like how to navigate this will be a little bit more apparent. But for now, I'll pause and take any questions about the browser statement. All right, so what do you think is one drawback of the browser statement? Oh, is there anything in the chat? I don't have the chat window open. Oh, okay, great. Helpful. I love that. Okay. Any ideas on drawbacks of the browser statement?
I don't know if I know a drawback yet, but I'm curious. Like, so I guess I've never used any real debugging techniques before. And my like approach to debugging is like setting like X equal to whatever in my console and then running line by line outside of any sort of like structure.
It's the same principle,
it's the same
except
thing.
it's easier to set the values and easier to run line by line. And you don't have to write side code to do it. Like you're just like doing it here.
Yeah.
It's the same exact thing, but much easier, cleaner. You're not populated by anything in your global environment.
Right. Okay. That's cool. I keep forgetting about that it's totally separate from the global environment.
And it's like, you know, setting those values one by one can get so tedious. And you don't have to do that. You just have to like have a function call and that's it. Like,
okay, maybe this is like jumping ahead, but like, does this work for something like a for loop, like setting I equal to something, or is this purely just for
if
function?
Your for loop is inside of a function, sure.
Okay,
but only if it's inside of a function, yeah.
Gotcha.
Other questions? All right, so the bad thing that you kind of saw me do earlier about the browser statement is that you have to remember to take it back out, right? Like if you fix your bug and you're like, oh yeah, now I actually just like want to use f of x, like take it out, resource your script. I'm done browsing, I'm done figuring all that out. Now let's do G of 1 and make sure it doesn't open my interactive debugger again. Otherwise, it's always going to keep triggering that interactive debugger. All right, so that's one way to get into your interactive debugger. That's just what we did. So, you know, just like we talked about, you can submit any sort of R commands you want to at that browse prompt. And stir, ls.stir are particularly helpful. ls lists all objects in your function space. And then here are the keyboard shortcuts. And I know it like popped off the screen there and okay. So in for next statement, if you want to use them, I'll show you an alternative too. In for next statement, C for continue, leaving the interactive debugging, S for stepping into functions. So you could have functions within functions within functions. You can step into those. F for finish, where, and Q to quit are the letters you can use. And note that Q is the only one that's capitalized. So I only demonstrated in there. And so these are the ways we talked about to debug your own code so far. We'll cover some more tools. But now it's time to get into an exercise. So someone tell me if you just want me to demonstrate the exercise. Yeah, probably.
I think that's probably the best thing. It sounds like a few people still can't get on.
All right, sorry. So let's get back. Now I'm in my Posit Cloud instance. You can alternatively, if you're confident and you're like building packages and whatever skills, you can follow along locally using the WTF debugging repo as well. This has most of that same stuff in here. All right, so I'm going to open up exercise 1, and I'm going to do the solution, which has like the most written out examples. So what we're going to do, and I'm going to scroll all the way to the top. I don't know why it's top to the bottom. Last time I was in California was actually for our Studio Conf 2020 in January 2020. And if you missed it, Jenny Bryan gave an amazing keynote that year, which is called Object of Type Closure is Not Subsettable. And this particular example we're actually using in these exercises are from that keynote, but modified slightly. So what we're going to do is I'm just going to open up this file for you. This is your source me file. These are the things that we want to be using to illustrate debugging. So we are going to be creating a data frame called fruit. And then we have this function that computes some sort of fruit average. And I will show you what these look like because I know it looks a little like gibberish here. So we're going to source that file. So now we have data and we have a function. Let's see here. Now, ooh, how is this font size? This looks kind of small. View. Where's my zoom in? Edit. Code. There we go. Okay. All right. So we're going to take a look at our fruit data, and it's not tidy data, but it is fruit data. So we have along the columns different types of fruit: blackberry, blueberry, peach, and plum. And along the rows, we have different attributes of our fruit, which include calories, weight, and some measure of yumminess. And fruit average is going to look for fruits of the same type, like berry, and compute the average of those fruits. So when I do fruit average for berry, I found 2 fruits, which should check out because we had a blackberry fruit and we had a blueberry fruit. And when we took the averages of the calories for those berry fruits, we have the calories of 2.5, and then the average for the weight and the average for the yumminess as well. But unfortunately, when we just enter peach, which is only going to result in a selection of a single column, we get this error. This, like, what does this mean? We have an error in row means X must be an array of at least 2 dimensions. So are there any questions about the setup before I proceed? All right. So the first thing we might want to do when we have an error is identify the location of the error. And honestly, I don't use these functions a lot, but I want to make sure you know that they're out there in case they are helpful for you. So we're going to use our traceback. Our traceback is a little bit richer than the examples I previously showed. So you can see 3 different steps here. First, we called fruit average. And then we tried to get into row means of something called mini-dot. You wrote that function because this is like an example where you wrote the function, but I know you didn't. So you probably have to like go back and remember what is mini-dot. And then you hit this like error that says stop. So I'm just going to copy and paste this here just so we can kind of reference it. So what if we want a richer traceback? So I'm going to set my options error equals rlang and trace. I'm going to call my fruit average and trigger an error. Now we have our error again, and now I'm going to call rlang last trace. And you can see here we have a different type of visual as far as like what our, I want this bar to go up. Okay. figure out how to make this minimal, but that's all right. So we have a different type of visual, and it says, it kind of gives you a little bit more detail, right? So we have this function called fruit average in our global environment that was called, and then from base R, there was something that called row means, and that happened at row 13, column 2 in our source me script. So we can still open up that source me script over here. So if we go down to row 13, column 2, yeah, that's like where it called row means, and that's kind of the source of the error right there. So you're going to get that richer traceback. And I'll just copy that there because let's do that. That's my exercise. Okay. And so now we want to do some interactive debugging. So I'm going to go over to my source me file and I'm going to modify it. Just for this instance, I'm going to put browser here at the top. But again, browser can go, actually, just for illustration, let me put it on the second line. It can go anywhere you want. So when I put browser after line 10, it means line 10 will be evaluated. And then we're going to start the interactive debugger. So if you have a sense of like where that error is, it might be more efficient to start that browser in different places. So now I need to save this file. I need to source this file. So now it is sourced and it has this browser statement in it. And now I want to trigger my interactive debugger again. Now, instead of triggering it on an error like Peach, I'm going to trigger it when we don't get an error. So you can kind of see what happens when we don't get an error. So it does actually open up that script for me. And it opens it up to the browser statement. And you can see we already have objects in our environment, which is what we would expect. We would expect our dat to be there, and we would expect our pattern to be there. These were arguments applied to the function. So our dat is our fruit data, our pattern is berry, and we also expect our calls to be there because our calls indicate the columns that correspond to the berry fruit. And that should have been executed because our browser statement is after it. So these are all the objects in our data set. I am going to go ahead and type in, sorry, in our function environment, I'm going to type in to execute the next row. So now I have, I'm ready to execute minidat. So what does minidat look like? Minidat, you can see now, is just the original data frame, but just with the berry column. So we have blackberry and blueberry, and that's what our minidat looks like. And then we can hit next again. And we found 2 fruits. That's the message. And now we want to execute row means, and our row means successfully executes. So let's repeat this exercise. And I'll do the same thing, but you can tell me if you can see what is different when I do it for Peach. All right. So again, we have opened up, we have our dat, that's our fruit. We have our pattern, that's Peach. We have the calls that we want to grab. So we're only grabbing the 3rd column instead of the first 2 columns. Let's do the next statement and execute minidat. Now I'm going to go ahead and look at minidat. And does anyone see what the difference is between minidat last time and minidat this time? I know I went over it kind of fast, but the last time we had 2 columns. Yeah, go ahead.
Is it that it's just the data and they used to be stacked as row values and now they're all in, or sorry, column values.
Yeah, when we had 2 columns and we did this kind of base R subsetting, the subsetting returned an object of like a data frame. When we have 1 column, the base R default is to return a vector instead of a data frame. Tricky. So that is what happens. So it's returning a vector instead of a data frame. And you cannot take row means of a vector. Just to illustrate what's going to happen, instead of using in will like just try to process row means and like just like show you that the error happens. I am going to hit S for step into. So now we're going to launch ourselves into row means. It gets a little wonky. We don't own row means. It's like a base R thing, but let's open it up. We're in row means now. So it has opened up the source code for, actually, I think that's the message one. Sorry, I think I did it too soon. Okay, let's do next. I'm gonna do C for continue. Okay, that was the message one. I didn't mean to open up the message one. The message one is fine. It's kind of fine, right? So like one thing that's different here is before you said it found 2 fruits. And here's kind of another clue that something's not quite right with Minidat. When you take in call, like of Minidat, like the number of columns, it's null because it's a vector. It's not a data frame. So that's another indication that something's not right with that message. And now I'm going to jump into row means, which I'm looked at a lot more than the message function. So let's step into row means. And now we are in the row means function, and like we are in the row means function environment here. So like in calls doesn't exist anymore, and Minidat or dat doesn't exist anymore. This is only what's being supplied to row means. So row means is getting some argument called x. You can see that x is a vector, and we can, it is a little like the highlighting is like a little buggy, like debug location is approximate because the source is not available, but you can still step through it, right? So I can still kind of execute this first row, like, you know, is it a data frame, convert it to a matrix, and I can go to this next row and it's like, I'm checking like some condition on the dimension of X. And we know that the dimension of X is null because it's not a matrix, it's a vector. And then that's kind of like exactly where you hit that like really weird error, stop X must be an array of 2 dimensions. All right. So we have gone through our function and navigated, kind of identified the error, the source of the error. Now, how crazy are you to know how to fix the bug right now? All right, you want to see the bug fix? It's actually like super simple, but I would have no idea that was here. So I'm just going to go over. So there is an option you can use, and I had no idea this existed. So if you're doing this base R subsetting, you can do comma drop equals false, and it will return that data frame instead of that vector. So I'll just show you and convince you real quick. So if we use this, I'll take out my browser statement, I'll save, I'll source, and then I'll do fruit average of peach. It did not work. Oh, I didn't put in the data. All right, and now it executes. And so when we do Minidat, it would return that data frame instead of just a vector. All right. So that is debugging round 1. We'll move on to debugging round 2, but first, before we do that, let's just take a quick stretch break. I am gonna go on mute and go off camera, and we will be back in 5 minutes. And feel free to pop in questions, and I can try to get to them as well.
Thanks, Shannon.
I'm happy to take any questions at all while, if you're still here. Enjoy your break if you're taking a break. I kind of like this starting at 8 p.m. for me because I was like, I did get a break after my workday. Like, I didn't have to go straight from work to this.
I was worried it was gonna be too late then, but it's working out.
Yeah.
I have a question. You
Yeah.
said that like usually folks have one or two techniques that they like gravitate towards. What are for debugging? Like what are your preferred strategies? Are these what we covered so far? The ones that you
No,
typically no?
we get to them in
Okay.
section 3.
Cool.
But I'm gonna make sure we get to them. Yeah. I mean, I like the interactive debugger. I don't use traceback, but there's like 10 different ways you can get into the interactive debugger.
Okay, cool.
If we go back up to kind of this slide, I kind of like to optimize the same tools that you can use both for my own code and for other people's codes. So like I'm looking for something that has a wizard hat and a magnifying glass and a ladybug.
Gotcha.
And there's only like a handful of those. So because you can use them like for general purpose, I like using these functions here.
Okay. Well, I'm excited to hear about them.
Yeah.
Also, these slides are beautiful, and I borrowed your little timers for one of my recent workshops, and it worked so well. Everyone got a kick out of it. So
that's awesome.
Stoked to see that that was a thing.
Yeah. All right, so I think we are at time and I can get started again. So we talked about inserting the browser statement, using traceback, using some rlang functions. These are things you can do in base R. Like you do not need RStudio to use these functions. Like you don't need the IDE. But there are some specific features in the IDE that make debugging easier, and some options you can leverage as well. So I'm going to show you what those things are in the IDE, in the RStudio IDE. So here's another way you can open the interactive debugger. It's called an editor breakpoint. And I used to do this by accident all the time before I even knew what this was. Like, what is this red dot? Like, why is it here? How did I accidentally get it there? It actually does something. So this red circle that you see here is called a breakpoint, which is exactly equivalent to inserting a browser statement, but you don't have to change your code. So I'm going to show you in my R session. So I am going to restart R. And I'm going to put an editor breakpoint over here on line 2. It says it's going to be activated when this file is sourced. So I'm going to go ahead and source it. And you can see that the browser statement is active because you can see the red dot here on my functions. And you can also see the red dot over here on the functions in my global environment. So now, regardless of whether or not I trigger an error or if I just execute the function as usual, like with G of 1, it's going to open that interactive browser exactly where that red dot is. So again, same thing you've already seen before, exactly equivalent to the browser statement, can use the same commands as before to execute and then terminate the operation. I mean, similar to browser, you have to remember to turn it off if you don't want to open the interactive debugger, but some people find it simpler or more appealing than in submitting a browser statement. Are there any questions about that? And again, you can put it on any line of your function. It doesn't have to be the top line. All right. Just like one quick note that when you do source that function with your interactive, with your breakpoint. When I source it now, I can click the source button. And just note it calls a different function. So it calls debug source instead of source. And that's how it knows how to leverage that breakpoint right there. Just a note for you in case you're using the source function itself. When we were in the interactive debugger, I did show you the keyboard commands in S, Q, all of that. You don't have to use those keyboard commands, so you can use the debugging console instead. So if I put that breakpoint on, I source my function, and now I trigger my interactive debugger either with an error or not. These buttons here do the same thing. N is for next, S is for step into. This one is like finish it all, and then C is for continue. S is for stop. That's that big Q for quit. So instead of putting in for next, I could just use these buttons as well.
Shannon, I'm not actually following along because I am monitoring multiple screens in the instance, but someone says that it doesn't seem to be working for them, the breakpoint that is. Do you have any tips for things to look for if it's not working correctly?
It does have to be over here to the left of the numbers. That's one thing. When my session was new, I did get this notice that breakpoints will be activated when this file is sourced. So it's like not yet active. So you do have to source that file. Another thing could be if you're like on a really older version of your IDE, like that could impact the functionality here. It shows the red dot, but doesn't launch the debugger when I wrote the code using most recent RStudio. I have no idea. The red dot is a closed red dot, not an open red dot. I don't know. That's weird. G of 1. It's not open. All right, that's something we'll have to troubleshoot a different day because I am not sure. This is weird. I'm happy to talk to you about that either after or offline or something. Yeah. Oh, you could have an interaction in your environment. So I'm going to show you some other things you can do in that. It probably wouldn't affect this. I'm going to show you some other things in your IDE that can kind of make things look different as well. So, and this is exactly what I was talking about here. So you do have some debug options in your IDE, like all of you do if you're using RStudio, and you probably all have it set on one of these three things, and you probably have like no idea what they are. So if you go to your debug menu, I know it's tiny. That is not making it any bigger. If you go to your debug menu and you scroll down to on error, there's just three options: message only, error inspector, and break in code. And they do three different things. So I'm going to copy this and show you. So I'm going to go over here. Session, restart R. I had to come up with a new example to kind of get these to work right. So here we're trying to do a string split on a vector. And the vector I'm trying to string split is just the character values A comma B, and that's going to return A comma A and the values A and B. But it does work on like a character value. It doesn't work on a factor value. So if I try to put it in on a factor, I'm going to get this error. I'm going to go over to my debug tools and I'm going to see what my settings are on. So my personal settings right now are on message only, which is exactly why you see a message. And that's the only thing you see when this is triggered. I'm going to change my debug settings right now. Instead of on error, I'm going to select error inspector. So sometimes this used to pop up for me and I would have no idea when or why this would pop up for me. But now that I have the error inspector triggered, you get this little gray box now. This gray box allows you to show the traceback, which we've already talked about, which shows you the sequence of steps that lead up to the error. And it's using the base R traceback function, not the R-lang traceback function. And then the other option here is to rerun with debug, which means open my interactive debugger. So now if I want to open my interactive debugger, it's so cute because it's taken me straight into the straight split function. Like, it's like, if you've ever clicked on that and you're like curious and you're like, maybe it'll take me somewhere helpful. And you're like, this is not a helpful place. Like, what am I doing here? I don't know. So I think it can be like a little jarring because it pops you, like, it would be like popping you straight into row means, and you'd be like, how did I get here? What happened? Like, you lose a little bit of that context. But it pops you exactly into the function where the error occurred. So I'm going to go ahead and stop that. So again, message only just shows you the message. The second option, which is on error inspector, allows you to select between traceback or rerun with debug. And then the third option, break in code, we're going to just run that again, just automatically opens the debugger. And it opens it to that same spot exactly where that error happened, with like not much context as to like how you got there. So I don't think that would have affected your browser statement, but it's issue, but it's possible. All right. Typically for me personally, I don't use these options because I like to see a little bit more of what's going on behind the scenes. So my default is usually just to put it on error message only. And then just one more thing to know about these error inspectors in the IDE. Like, I don't want to get into the nitty gritty of it, but it really only triggers if R detects that it is your code that is involved. So if it's like calling a function like in a package, it's probably not going to trigger these error inspectors. So like, really, if you're just working locally on your own code, that's when it's used most. But you can also change these options in tools, global options, and uncheck use debug error handler only when my code contains an error. It can open that up to also more broad code as well, if you wanted to. All right. So I am going to jump into my exercises now. We are going to demonstrate the breakpoint and maybe some of these on error debug tools as well. But the format that we're looking in is going to be a little bit different. Are there any questions before I jump into the exercise? All right. So yeah, I have a feeling that would happen. So just to kind of refresh ourselves as to what we did in the first exercise, we only had one function called fruit average, and then there's like several steps in our fruit average function. And the setup for exercise 2 is just a little bit different, so you can really kind of take advantage of the step into. So I'm going to restart R. Nothing's in my environment. I'm going to open up exercise 2. I'm going to open up the solution and scroll up to the top. So let's open up our source me file. And you can see that we still have our fruit data set at the top. That's fine. But now we have a series of, and I've got my debugger on. Okay. And now we have a series of mini functions that compose together to create the fruit average function. So we have find calls function, reduce dat function, message fruit function, compute average function, and all of these are 4 functions, mini functions go into computing fruit average. So it's a little bit of a different setup now. So I'm going to source in the function, and now we can see fruit is in our global environment, as well as all of these little mini functions, including fruit average. So again, we can see fruit, convince ourselves that it's there, convince ourselves that it works for berry, and again, convince ourselves that we have an error when we try to do it for peach. So let's go ahead and put in our traceback. Here's where kind of you might kind of start to see some of the power of this traceback, because we did go into so many different functions. So first we went to fruit average, then we went to compute average, and then in compute average is when we hit that row means function, and that's when we stopped. So kind of goes through those steps of that function. I'll show you the richer traceback now that we have this. And again, it's going to tell you kind of exactly where these functions live. And oh yeah, these are showing a little bit more of a different error. So here we have the last error, which kind of like lists out the steps. And when you do last trace, it kind of shows the nesting of the steps a little bit more clearly. So we see that we called fruit average from the global environment, we called compute average from the global environment, and then within compute average, we went to the base R function row means, and that's exactly where we hit our error. It's a little bit of a nicer view. All right. So now we are going to start the debugger by inserting a breakpoint. I'm going to put this breakpoint into wherever I want to, but I'll just put it on line 29. I'm going to restart R, start with a blank workspace. I am going to read in the source me with debug source instead of just source, so that it can recognize that breakpoint. I'm going to trigger the interactive debugger. And we should already see a lot in our environment. So we should already see calls. We should already see minidat. We have not yet triggered message fruit. So message fruit will happen after I could hit N to execute it, or I could hit S to step into. So I can step into that message fruit function if I wanted to, like, oh, is that the source of the problem? I don't know, like let's hit in and execute that line, the message line, and again. And well, so my message executed, even though it didn't quite return what I wanted it to return, it found blank fruits, but that's okay. So now I'm on compute average, and I'm going to again hit S to step into. So now I'm stepping into the compute average function, and maybe I want to step in. I could either hit in to execute that row means function, which will terminate the process because it yields an error, or I could hit S to step into the row means function again, if we were feeling brave and wanting to look at base R code. And we could again continue like next, 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 and then we've hit our error and it kicks us back out of the debugger. Are there any questions? Okay. If we just kind of want to, I'm going to take the browser statement off. I'm going to restart R. I am going to source again. So I have no breakpoint set at all. Now I'll go to debug, and on error, right now it's message only. So right. So fruit average of peach is only giving a message. So now if I go to on error error inspector. Let me make sure that's checked on error inspector. And then my up button isn't working to recall the last line. Okay, there it is. So fruit average, nothing different happened. Okay. I would have expected it to show that gray bar where you could either see the traceback or break into your code. That didn't happen. I don't know why. Let's see if the break into your code works. Let's see, fruit average now. All right, well, the break into the code worked. Maybe it's something a little glitchy with this instance. So when your debug option is break into code on error, it's automatically going to open up that debugger straight where that error happened. And it's not like exactly, I mean, it's kind of telling you like you're in the function row means that is in base R, and somewhere in this row means function is where things go awry. All right. That is what I wanted to show you about debugging in the IDE. Are there any questions before we move on to the next section? Okay. All right, so now what if you need to debug their code? So this is not your code. This is not something where you have a script or your own package. So something where you've installed something from CRAN or from GitHub and you don't really have access to the source, but you need to break into it. And because you don't have access to the source, it means you cannot physically go into the script and type in browser. And you cannot physically open the script and put the little red breakpoint on there, right? Like those are options that you do not have when you don't have the source code. So you still need to be able to do debugging. There are options you can use. Right. So the first option you can use is the function debug. The debug function is equivalent to either putting a browser statement or a breakpoint in the very first line of your function. Works the exact same. Now, the one thing about the debug function, let's see here, I will demonstrate it. R, okay, I'm going to remove my breakpoint. I am going to restart R and clear my environment. Okay, so let's go ahead and source this in again. So we've got F and G now, and I said, okay, we're going to use the debug function. It's going to work the same as a browser statement or as a breakpoint. And I want to debug the function G. Okay, nothing happens, like, okay, cool. But to trigger it, you still have to execute it, either in something you anticipate yielding an error or something you anticipate not yielding an error, whatever you want to do. Now that has been triggered. So we are now live in our interactive debugger, and we can proceed as usual in our interactive debugger. You notice you get this same notice that you're getting that row means. Debug location is approximate because the source is not available, even though you have the source, like not recognizing that because you didn't, yeah, because of the way the debug function is working. And it opened up G in a separate script here. And yeah, you can just keep going through your debug commands and for next, and it yielded 2. It was successful execution and it exited the debugger. All right, so great, we're out of the debugger. So let's like run our function again, and we're back in the debugger. Oh wait, I didn't want to be in. Wait, let's get out of it. Okay, and we'll just like run our function again. Okay, oh, we're back in the debugger. So what debug does is you stay in the debugger until you run the undebug command. So we're going to do undebug, and we will do G. And now we can use G as usual. So debug, again, it's the same thing as opening the interactive debugger, either via browser or breakpoint. It's going to be initiated every time G is executed until you remember to undebug it. And sometimes people say that they can get trapped in the debugger and not like get back out. That like hasn't happened to me personally much or ever, but I've heard it happening. And for those reasons, sometimes people stay away from the debug function because it is eternal until you undebug. Any questions?
There's one in the chat.
Mm-hmm.
What would be the use case for using debug instead of breakpoints or browser?
Yeah. So the use case is you don't own the code. And I'll show you that in exercise 3, where we simulate using code in a package instead of using code in your own script. So because, again, if you're using breakpoints or browser, you're assuming you have the scripts and you can modify those scripts. If you don't have the scripts and you can't modify them, then you need to use a different tool. Are there other questions? No problem. All right. So this is the one I personally use the most, but like I have like very talented programming friends who don't use this. Like they love the breakpoint or they love the browser statement. Like everyone likes their own, but this is the one I use the most, is debug once. Because I know it'll get me in the debugger and it'll get me back out. So debug once is the same as the browser or breakpoint in the first line of the function, but it does it for one time only. So you don't have to remember to keep to undebug. It only goes into the browser a single time. Just like if you feel like you're going to be debugging for a while, you need to keep going back in there. You just have to keep rerunning debug once, which is fine by me because otherwise I'll forget to take the browser statement out. I'll forget to take the breakpoint out. I'll forget all of that. So all you do is debug once on G. Nothing looks any different, but you call G of 1. And now I'm in my interactive debugger and I hit next and I exited. And now I want to just, hey, everything worked. I want to run G again and I can run G again. I don't have to remember to undebug it. But if I do feel like I need to get back into the debugger, I have to re-execute debug once. Then I have to call G again on whatever I want to call it. I can do stir, see what's in my environment and be like, oh, it's a character value. No, I see. And get back out. So debug once is my go-to, but other people use breakpoints and other people use browsers. And one disadvantage of debug once is if like you have a really long function and you don't want to start at the top, like you want like 100 lines of code to be executed or something like that before you get there. Like then you might want to use your browser or your breakpoint if it is a function that you own the source code for. And I'll flag kind of this thing here. So like debug once opens that interactive debugger, and you can use it for your code and for their code, which is different than the breakpoints, right? So the breakpoints are just for your code, also different than the browser statement, which is just for your code. All right. There's all sorts of different kinds of error options you can use as well. We already talked about error equals rlang and trace to get that kind of nicer traceback picture on error. Another kind of fun one you can use is options error equals recover. So that's totally different. It gives you frames and you can select frames to enter the debugger on. And you can think of like a frame as like each separate little execution in your line of code. So I will copy this for a recover example and show you. I think I have it right here. Okay. So I'm going to restart R. I'm going to clear this. I'm going to source my functions. I'm going to set my options to recover. If I don't want it to be there anymore, I can just set error equals null. So options error equals recover. I can always set error equals null to turn off those options. Nothing's happened yet. I'm going to trigger my function. And I see the error, and then it allows me interactively to select the frame I want to enter. So it's giving me two choices. I can go into my G of A frame, or I can go into my functions at row 5 where it calls f of x. So let's see here. I'll select one and see what happens. It's called from the top level. It's a little bit mysterious up there because there's not much in that. And I hit next and it like exited out. Basically, because like G of A doesn't do much by itself. So maybe I want to select a different frame to explore. So when you select that frame, you don't get to go to other frames. Like you don't get to keep going next and next and next and work sequentially through your debugger. You're just like looking at that one frame in isolation by itself. So I'm going to try frame 2. Frame 2 is where I go into the body of f of x, and I can see that I'm trying to execute x plus 1. I'm going to hit next, and x plus 1 was executed, and it's like taking me back out to that frame to explore again. So maybe I want to try to execute this in my environment and like see the error. I don't know what that was. Haven't seen that one before. Yeah, we're going to get out of this. But basically, that error equals recover allows you to go into each frame individually, live in that frame in its own contained little environment and explore what's happening in that specific step. I don't use it much. Any questions that I probably won't be able to answer? Okay, so we talked about the advantages of the browser and the breakpoint compared to debug and debug one, or that like you can move them, like you can put them wherever you want to put them in the body of your function to kind of execute as many lines of code as you want to before you open that interactive debugger. But you can only use those on your code. So what if you want to do it on someone else's code? Like someone else's code, you need to debug, and you want to debug it in a way such that you don't start debugging on the first line. You get to like decide where you get into that function. And that's where trace comes in. So the trace allows you to input a function and the what argument. So you're going to trace like the G function or whatever. And when you execute it with tracer equals browser, that's exactly equivalent to inserting browser in the first line of the function. So it's exactly equivalent to debug of your function. But where the power of trace comes in, and the only reason I would use it for more advanced debugging is if you wanted to put it at a specific location in your function, like you need it to evaluate 10 steps. So you can add this at argument here. So, and the at argument would insert your browser statement at the second step of the function instead of the first step. So that's where the power of the trace function comes in. Again, like debug, where you need to undebug the function, for trace, you also need to remember to untrace that function to terminate the execution of the interactive debugger upon call. All right. I will do a quick demonstration of trace without going into too much detail. I'll restart the session. So just for example, because we were already talking about row means, I pulled up a call sums function. So call sums is also like row means, where it's expecting a data frame, and when you input a vector, you get an error. So if I wanted to pull up the debugger on call sums, and call sums is code I do not own, so I could say debug, or I could say debug once on call sums, but I can't use my breakpoint, and I can't insert a browser statement. So another way I could execute this is to do trace of call sums with a browser statement. It's giving you this note that you're tracing it. And now I'm going to open it up or trigger the debugger by executing the function, expecting an error. And now, kind of just similar to the row means code, you're seeing very similar syntax, and you can go through your debugging steps and kind of figure out, that like, oh, hey, like I have a vector, and that's probably the issue here. Now remember, it's going to keep triggering that interactive debugger until I untrace it. And then the power would come in if you wanted to say like at equals 2 or something like that. And then it's going to kind of move where it's evaluating or opening that interactive debugger down a few steps. Honestly, like the next part is a little bit complicated. So I'm going to jump over to the exercise. Like if you're really into this, like reach out to me and like ask me about it. It's a little complicated. So I'm going to jump into the next exercise so we can just kind of hopefully drive home the functionality of debug and debug one. So we're going to close these files. We're going to restart R. And we are going to open exercise 3. So there's nothing in my environment. And instead of sourcing our own script, we're going to use a package. So there's this little package I created on GitHub. It's called WTF debug. And we are going to attach the package. And if you go over to your packages in the Posit Cloud instance, if you have access, you can see it's just got a few functions in it, like the compute average, like basically the same setup that you saw before, but now it's in packaged up in a package. And we've got our fruit average function as well. But there's nothing in our environment, right? Like, so I don't have access to this source script. I cannot put in a breakpoint. I cannot put in a browser statement, but I need to get in and I need to debug this. The fruit data is still loaded in our WTF debug package. So I can view it. I can confirm a successful execution, and I can observe my error. And then you can still use traceback to figure out where that error happened. You can still use your richer traceback with your options from rlang and trace. And notice like it kind of tells you like where the source of that stuff, of those functions are coming from. So fruit average was found in the WTF debug package, and compute average was found in the WTF debug package. And then it went into base where we found our row means, and that's where that error happened. And now, since I don't have the source code, one option I have for debugging is the debug once function, which is what I most commonly use, but you do whatever works best for you. So I'm going to trigger or set the interactive debugger, and now I'm going to trigger it by calling the function either on an error or not an error. And just like you saw before, it's still opening up the script with the source code. It's like a little confused. It's like debug location is approximate because like I don't have this script on my machine, but I found it for you. And we can still continue on with our regular debugging steps, doing next, next, finding our message that's blank. We could still go step into and go into our row means if we really wanted to. And then we could still keep going next, 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 and then get back out of the debugger once we hit our error. And if we were to call it again, we would just not trigger that interactive debugger because we said debug once. If you wanted it to stay on, you would use debug instead. If you wanted to see this error equals recover option, might look a little bit more contextual with the richness of this function and the different steps. So let's see what happens. So I've set the options error equals recover. Nothing looks any different in my R instance. I'm going to trigger the recover to pull up those frames to choose from by executing the function. And now it's giving me 3 frames I can choose from. So I can choose from fruit average, compute average, and row means. So let's see what happens when I go into fruit average. When I go into fruit average, I can kind of see I'm in this top level function. I can see a few of the values that were automatically loaded in. I pressed 1, right? Yeah. So it's done everything here except for execute compute average, it looks like. So I have minidat in here and I can explore and look at minidat and see, oh, it's a vector, it's probably a problem. I can hit next. And when I hit next, I think it's going to kick me back out and allow me to select the frame. So I'm only seeing like what's here in this one instance. So now it's kicked me back out and it said like, okay, well, you're done. Like you've reached the end of that first frame. Let's try a different frame. So now I'm going into my compute average frame and I can see the input to the compute average frame. What's going into it is minidat over here. Then again, I can hit next. And it's like, well, you've done all there was to do in compute average. Would you like to try row means now? Maybe I can go into row means. And now I see everything that has gone into my row means function and the value that was input into it, the vector, and kind of keep going from there. And then it went really quickly, but I hit in and it like would have hit the error right there, but it like kind of kicked me back out into the frame selection again. I don't use this one much, but I can see its use. I just haven't used it personally. All right. And I will show you, if you want to enter your fruit average function, I don't know, I can show you real quick. You can do this really weird thing where you can convert the body of a function to a list and take a look at it. So these are kind of like the steps of your function, and you could use this to identify the exact location where you wanted to go into a function if you did not own it. So this is like calling the compute average step. So if I wanted to dive into a fruit average function at exactly this step, rather than just starting with a browser statement at the top where you would do that with debug and debug once, you can tell it exactly what step you want to dive into. So here we're going to do trace of our fruit average with our browser statement at the specific location. It tells you that you're tracing it. Now you got to trigger that interactive debugger. And now we should have executed everything up until compute average, because I think that's where the trace was. So we can see all these things already exist in our function environment. And I hit, I think I need to turn off my options. Yeah, I forgot to execute this. So I was trying to go back into my cowboy error recover. Okay, so let's do that again. So now we're going to trace, trigger it, We have all of these things in our environment, and we can kind of step into the compute average, step into row mean. So the trace is just a really sophisticated way to debug a function that you don't own the source code for, where you want to get into a very specific step. And don't forget to untrace. All right, I think, are there any questions before I kind of summarize what we talked about? All right. So in that section, we talked about tools for debugging code that you don't own. That's the debug once, trace, and error equals recover will allow you to break into those tools, break into that code. Pick your favorite. Like, you don't have to use all of these tools. Like there's 3 tools you can use for tracebacks. There's like 7, 8 tools you can use for the interactive debugger. Just pick one that works for you. It doesn't matter which one it is. There are special cases for debugging. We're not going to talk about them, but like, you might want to be debugging in R Markdown. And like, the first thing you want to, like, it's, every time I say this, people are like, I did not know you could do that. So if you're ever like having trouble in R Markdown, one thing that I do is I insert the code knit exit, which will exit my R Markdown document at a very specific place, wherever I put that code. So I can kind of iteratively work through where the errors might be occurring. So just a troubleshooting tip there. But there's more on debugging in R Markdown in these links. Debugging and piped expressions, like if your function has a lot of piped expressions, like it could get like kind of ugly. So there's like some errors you might want to try, or some options you might want to try if you're facing that sort of thing. There's also things you can do with warnings. So we didn't even really talk about warnings. We only talked about errors. But if you want to kind of explore more why warnings are happening, there are options for warnings as well. So options warn equals 0 is your default warning. But you can change the options for warnings. So like, if you want your warning converted to an error so that you can get in and debug why that warning is happening, you can say options warn equals 2. And then it's going to treat that warning like an error and allow you to trigger your interactive debugger. So those are debugging special cases. I'm going to skip over this, read the source stuff, but I'll just summarize that, you know, we talked about basic troubleshooting steps, some like proper debugging steps. And I think once you get into the debugger, I find it so much more efficient trying to figure out where my problem actually is. But of course, you'll always learn something new when you solve that problem. So that is all I have for you today.